Study? What is that?
Study? What topic?
Hello, Quantifiers. Our finance is just around the corner, remember?
Yes, I remember that. I did, but I didn't understand anything.
Do you understand?
Kind of.
What about we ask video?
Good idea.
Video.
Yes, why?
Can you explain to us about quantifier?
Sure.
A quantifier is a symbol, a word, or a phrase that expresses quantities. It is divided into two types, which are universal quantifier and existential quantifier. The symbol for universal quantifier is pronounced as turn A, while the symbol for existential quantifier is pronounced as turn E. The symbol for universal quantifier is denoted as turn AX or turn AXY, which are read as for all x, for any x, for each x or for every x, or for all x and y, for any x and y, or for each x and y, or for every x and y respectively. The existential quantifier will be denoted as turn EX or turn EXY, which are read as for at least one x, for some x, or there exists some x, or for at least one x and y, for some x and y, or there exists some x and y respectively. The key difference between these two quantifiers is the universal quantifier applies to every element in the domain. Else, the statement will be completely false, even if only one of the element is false. On the contrary, the existential quantifier only needs at least one element in the domain for the statement to be true, and will only be false completely if all the elements in the domain are false.
For this statement, the universal set is the set of all real numbers. The given statement, which is for all real numbers x, x squared is greater than or equal to x. To disprove a universal statement, only one counterexample is sufficient. Let's x equal to 0.5. Then x squared we will get 0.25. Since 0.25 is less than 0.5, the inequality x squared greater than x is not satisfied. Therefore, the statement is false. For this statement, the universal set is the set of all real numbers. The given statement is, which means there exists a real number y such that y squared minus 3y plus 2 equal to 0. First, we have to solve the quadratic equation, which is y squared minus 3y plus 2 equal to 0. We're factorizing it, and we got y minus 1 and y minus 2. So this gives y equal to 1 or y equal to. Let y equal to 1. We substitute it into the equation, then we will get 0. Since at least one real value of y satisfies the equation, this statement is true. Next, for the universal of all integers like px, qx, and rx, the following open statement: px, x is greater than 0, qx, x is even, rx is x is divisible by 5. Write the following statement in symbolic form using quantifiers and determine their truth values. First, at least an integer is even. Second, if x is even, then x is not divisible by 5. For the solution, symbolic form is there exists at least one integer that is even. Let x equal to 2. 2 is an integer and it is even. This equation is true. Second question, symbolic form is for every integer x. If x is even, then x is not divisible by 5. Let x equal to 10. 10 is even and divisible by 5. This equation is false because of the conclusion is false.
Hi guys, this slide explains the concept of nested quantifiers, which happen when universal and existential quantifiers appear together in one statement. These are example questions that I will explain in the next slide. The question is to justify the answer by giving an example or counter-example. On the right side of this slide, we can see the rules for nested quantifiers. When negating nested quantifiers, each quantifier must be changed to its opposite. A universal quantifier for all becomes an existential quantifier. There exists an existential quantifier becomes a universal quantifier. At the same time, the predicate inside the statement is also negated. This rule applies to all quantifiers in the statement to ensure that the truth value of the original statement is correctly reversed. For example 2, we are given two statements involve nested quantifiers. We are required to determine the truth value of each statement based on the given universal set. For the statement 1, the first statement is for all x, there exists y such that x plus y equal to 3, where the universal set is the set of positive integers. To justify this, let x equal to 3, then y equal to 3 minus 3 equal to 0. However, 0 is not a positive integer, so y does not belong to the universal set. Therefore, the statement is false. For the statement 2, the second statement is there exists x and y, such that 2x plus 3 equal to plus y, where the universal set is 0, 1, 2. Let x equal to 0 and y equal to 1. Substitute these values, we get 2 times plus 3 equal to plus 1 equal to 3. Since both values satisfy the equation and belong to universal set, the statement is true. For the conclusions, the first statement is false while the second statement is true, based on the given universal sets. For the next questions, we are given the statement, there exists x and y such that 2x plus y equal to 5 and x minus 3y equal to negative 8. This statement means that there exists at least one value of x and one value of y that satisfy both equations at the same time. First, we take the first equations, which is 2x plus y equal to 5. We rearrange these equations to make y the subject, so y equal to 5 minus 2x. Next, we substitute these expressions for y into the second equations, which is x minus 3y equal to negative 8. X minus 3 times 5 minus 2x equal to negative x. Now we simplify the equations. So x minus 15 plus 6x equal to negative 8. So the answer can be 7x equal to 7, so x equal to 1. After find the value of x, we substitute x equal to 1 back into the equation y equal to 5 minus 2x to find y. Y equal to 5 minus 2 times 1, so y equal to 3. Therefore, we have found values x equal to 1 and y equal to 3 that satisfy both equations. Since there exists a pair of values x, y that makes both statements true, we can conclude that the given statement is true.
Now, let's move on to the negation quantifier. Negation quantifier is an operator that creates a new statement which reverses the truth value of the original statement. The symbol for negation can be 2 like this or like that. And then the rules of negative statement. First, if it's negation all x px, it will be existent x negation px. So next negation exists x px, it will be all x negation px. Next negation all x negation px, it will be exists x negation px. And then the final will be exists x px. So like the last one, negation, as is x, negation px, it will be all x, negation px, and the final will be all x px. Now let's move on to the example 3. For the first question, write the negation of the following statement. First, all students pass the final exam. The answer will be some students do not pass the final exam. We just change all to some and pass to do not pass. Next, a few of the books are not available in the library. So the answer will be all of the books are available in the library. So for the last question, every student in the class has a calculator. So the answer will be at least one student in the class does not have a calculator. We just change every to at least, and then class has a calculator to class does not have a calculator. And then for the next question, for all real numbers m and n, m is not equal to n implies that m squared plus n squared greater than 0. Negate the quantified statement in symbolic form. For the answer, first we change the quantified statement into the symbolic form, which will be all m, all n, m is not equal to n implies m squared plus n squared greater than 0. And then we put the negation symbol at the in front, and then it will be as is m, as is n, negation m is not equal to n implies m squared plus n squared greater than 0. And then we use conditional identity. It will be as is m, as is n, negation m is not equal to n, or m squared plus n squared greater than 0. And then we use De Morgan's law. It will be as negation m is not equal to n, and negation m squared plus n squared greater than 0. And then we just simplify at the back equation, m squared plus n squared greater than 0. We just change the symbol from greater to less than and equal. And then the final answer will be as is m, as is n, negation m is not equal to n, and m squared plus n squared greater less than and equal to 0. And then lastly, for the conclusion, logic and proof play an important role in solving mathematical problems because they help us understand and justify the solution. Through proof, we can ensure that the method used are correct and reliable. In addition, having a clear understanding of mathematical definition allows us to expand our knowledge and apply concepts more effectively when solving different types of problems.